David, thank you for coming and presenting, and I'll turn it over to you.
All right. Hi. Thanks for coming today and for inviting me to do this. So this is really an amazing time in development of this system. It's been underway for about 3 years now, and has just become operational through the National Weather Service. Some parts of it are operational now. This map on the left here is a recent photocopy and a recent screenshot. And the system that I'll be talking about is something we're doing in Texas. It's funded from FEMA flood response funding out of the May 2015 floods. It took a while to get that funding in place, but that's the money that paid for the study that I'm going to talk to you about. And we got this through the Texas the Texas Division of Emergency Management, which is part of DPS, the Department of Public Safety. The funding is for a couple of years, and we're developing a state prototype as well as local prototypes and for flood planning, and then we conducted some tabletop exercises to work this out through with the TDEM folks. And what you're seeing here is the results of the first year of our study, and this is looking pretty good. We're working with quite a lot of partners at all levels. Dr. David Maidman is our main federal contact. The public safety liaison, Harry Evans, is kind of the project program lead, and he's former chief of staff for the Austin Fire Department, and he's the one who's really connected us with this community on the county and city level. Without him, we wouldn't have been able to get past the firewalls. No pun intended. So the real question we're addressing here is how do we go from a radar rain map to a flood inundation map? The radar rain map is what you see on the evening news and what the TDEM State Operations Center shows on the screens during a regional flood event. They don't show the one on the right. They don't show inundation and potential impacts. And that's where we're headed. So what we're proposing, and when I say we, I'm really talking about TDEM and David Maidman and Harry Evans. They're the key guys. I've been doing the GIS work on this, and I've been working in related fields, but they're the ones driving this project. And what we're working on are on multiple levels. One level is just getting an inundation map. What does it look like for flood planning, and what does it look like for real time? There's a fair bit of discussion that goes on, and what we want to provide at the local level for local use is a strategic flood response-based map that then can be used for incident response. So those are the various products. Now, one of the things you guys probably know that FEMA does not cover, they do not have flood risk maps for the whole state. In fact, they don't even have half the state. So, and Blanco County got hit real hard in May 2015, and since then, and Wimberley's gotten 2 major record floods in a recent period. Wharton County down just west of Houston got some flooding just in January, and it doesn't have a flood map. So what we're doing is trying to work around this. And one of the pieces of information that we realized we needed was a population map, a address point map, because that's how they task the resources. It's based on how many address points are in the affected area. And there wasn't a harmonized statewide address point map. So it's taken most of this last year to collect that, and that's the part I've been doing. This is the jurisdiction landscape. There are quite a number of entities involved. It turns out that this Commission on State Emergency Communications down in the lower right corner there, they're the ones that coordinate the address points for all but the gray counties. So the regional planning commissions and the emergency communication districts and the municipal emergency communication districts all come from different sources. But CSEC, this handles the colored counties. For the gray ones, the ECDs, we were able to get through to those through the Texas 911 Alliance. And for the municipal emergency communication districts, I was able to get those through somebody based up in Dallas with the emergency GIS response team. So this is all really coming from the public safety community, and it's for public safety. It's not for general public. The address points themselves are going to be hosted at TENRIS for production and maintenance, but not with elevation data. So elevations, let me talk about this. Now, I don't know how many of you may have heard of height above nearest drainage, but it's like a DEM raster elevation model where the point on the map is based on the vertical elevation from any point from the nearest drain line. And so there's a set of hydrologic processes that have been developed for determining that value. And what we've done is assign that value to each address point. This is what the elevation, the hand elevation looks like for Texas, where dark blue you could think of as flatter, and the white areas as steeper. And this has actually been done for the entire country. It takes about a day to generate this on a supercomputer up at University of Illinois. That's where they've worked out all the data, and they've got it all sitting up there. The Texas database itself for this raster is 50 gigabytes. The whole US is quite a bit more than that. But what I've done is to do the extract cell value from that raster and assign it to each address point. And this is what it looks like at the state level. And that's not very useful. Down at the local level, this is in South Austin. You see the red points show addresses that are within 10 feet of stream bed, and green is 60 feet or higher. And we don't have a lot of elevation in Texas, but this works out really well. The blue shade in the background is the hand elevation itself. And that's the DEM. So that has shown to be fairly consistent with what elevation maps have been done. This map in the inset was done by the Austin Fire Department just in the last year. They've done a lot of studies to come up with something that could be carried by firemen in the truck. And this is what they came up with. That's why they've chosen the colors so that they're red light readable inside the cab. They summarize the address counts according to flood level. This is a flood risk planning map, this one in the inset. And that's what this map on the screen is useful for, is really for planning. It's for looking for potential impacts. And the blue dots on the streams are dams, the brown dots are bridges, and then I've also got transportation on there. So this is the approach that we're using for communication of the flood risk. And the Austin Fire Department developed a set of maps, and what we're going to do is create a set of templates that can be shared with anybody in the state. It turns out that this inset here in the lower left is quite expensive. It costs several $1,000s to generate that one map. Ours is a matter of a few minutes of processing time, and it's available all over the state. It's just not equally accurate all over the state. It's fairly accurate in the hill country. It is not very accurate in the coastal areas. So that's something I'll be talking about in a little bit. This is a map that Wharton County uses for planning evacuations. And we went to their EOC, their Emergency Operations Center, and got to see their evac maps. This is what they actually use for real-time flood response. This is a map under glass. They use a whiteboard marker and write on roads that are closed and wipe it out and put on something else for fire and wipe it out and put on something else for tornadoes. It just depends what the problem is. And this is a real key bit of information, that these maps have to be simple to be usable. And they need to be under glass or on a screen on the wall in a GIS to be usable. Whatever we might do, that if it's just rolled up and on a shelf, it's not going to get pulled out during an event. So we've developed these base map templates for use at local counties. Here's one for Wharton. Here's one for Blanco. You won't see any evacuation routes in Blanco. They don't need them. That's not their issue. But this is what we've worked out so far. And then what the local communities can do is take, let's say, take a large area map, circle the areas of flood risk, and develop more in-depth maps at closer scale. This is what the legend looks like on the Austin map. And those flood gauge heights up there in the top are actually fairly standard across the city, but they might vary depending on where in the state you are. And so that's something that takes local intelligence and local development, but the template is usable, and it's actually not that hard to create this GIS map for GIS people. It's not, but it just takes some development, and we do have these for templates. Okay, so for the first year of the 2 years, we've gotten fairly far along. These are what we wanted to develop, and we've conducted all these, and we're moving ahead with the taking a pilot and developing final. Now this map it's an animation of flooding from the May to July period in 2015, and coming up right about in the next few days, down in the lower right corner, you see there's the flooding from the May 2015. There it is, the Memorial Day floods in Central Texas. So this is what the National Water Model is now cranking out operationally since August. The local, the version that's posted on the web is right here at this URL, and it color codes these streams by their anomaly. And by anomaly, I mean their current stream flow value difference from average. And they're basing the average on a 23-year historical record. And these are updated every hour. There's an hourly update of the current conditions, which is their analysis curve. I'll show what these look like a little later. There's a short range, which is looking 18 hours ahead at hourly increments, and that's updated hourly. There's a medium range looking 10 days ahead that's updated every 6 hourly, and then a long range looking 30 days ahead. And there's this is based on an ensemble of multiple forecasts. The output of these forecasts is something that you can actually get your hands on in NetCDF format. This is an example down in the bottom. These are medium range for a certain channel, and 33 meg is one forecast. And so there's it's about a few terabytes a day of forecasts. And so they don't keep more than 2 or 3 days at a time, and for the National Weather Service itself. But there's various groups, like here in Texas, we want to hang on to as much of this as we can for study. And so HydroShare is making that, is providing a site where this can be funneled off to. The other thing is that AccuWeather and weather.com and those guys are going to start working with this. Now, this is an example of a flood inundation map that the National Weather Service has developed with Corps of Engineers' help. And as you pick your height on this chart here, the inundation changes, but that is a very costly. It would cost about $15 million to do that just over the state of Texas. It's not going to happen. And what we've done with the National Hydrographic Data Set, NHD Plus, and the National Water Model is available at quite a low incremental cost. So we're not presenting this for flood insurance use. This is for public safety and flood response use. So we need to be clear about that. We're not trying to overtake this other industry. But, and there's a number of checks that need to be done. We've checked this in the hill country and it works quite well. It matches quite well with HEC-RAS and cross-section analysis and with USGS gauging stations. This map here of integrity checks with gauging stations shows that the red and the blue are off high or low. The green are in the middle. And so we're getting pretty good agreement with the gauging sites, but not perfect. And so again, this is really for flood response, for emergency response use. And the thing we have to watch out is that perfect is the enemy of good. The public safety community needs this as quick as possible. They don't need it to be 100% accurate. They just need it as quick as possible and seconds count. So that's the goal for this. Here's an example of the National Water Service, the National Water Model discharge. And what we've developed as part of this study project are two different products coming out of this. One is developed by Kisters, a water engineering firm, and they have a viewer, which I'll show you in a bit, that can that will map out not just the discharge, which is coming from the National Water Model, cubic feet per second. They'll also come up with a water level, which is based on an average rating curve for each stream reach. Each of the 100,000 stream reaches in Texas has an average rating curve, and they are applying that to go from the discharge to the water level. That's not to generate an inundation map. This is what we're generating from the height above nearest drainage, and I'll show you that in a minute. Esri has developed a potential impact map, and this is at a real alpha stage, and I'm not going to show this one, but I will be showing you the Kisters. So this is the potential operation flow that we want to bring about. So we're not just seeing rain maps, but we're also getting to flood maps. And the National Weather Service itself is going to be publishing inundation maps. They're working that out right now. They're publishing the stream flow maps, it's operational, but they're still working out the inundation maps. And they're going to be publishing those through the National Weather Service regional offices because they need to be ground truthed and checked, and the National Weather Service are the folks that will be providing an authoritative look at the inundation. So that will be coming out in real time. And you could think of it like the National Storm Center in Norman, Oklahoma, is publishing tornado risk maps and tornado maps. They're notifying the regional offices of tornadoes in tornado potential in their areas and what their likely zones of impact are. That's what the National Water Center in Tuscaloosa will be doing, and through the National Weather Service regional offices. So here's the Kisters map, and I'm just going switch out of here for a moment and go to the live map. This one is, this is available, but it is a prototype, and I want to ask that you don't all hit this at once, but I can zoom in and let me go find an area where there's some storms. Here's one, and here's a stream gauge. Oh, seems that the storms have moved. Let me go to, let's pick this one here. And what it's showing is the national water model output for the forecast. And I can click up here and see the both the short term and medium term are displayed here. And the blue dots are actual stream gauge observations. So this is the analysis curve, and this is the medium range. And then here it is translated to stream depth. Now this is always interesting. So we have one model of a forecast of the stream depth, and that's quite a bit different from this forecast down here. I'm not quite sure why. So this is why we want to not say that this is authoritative. It goes through the National Weather Service Regional Office for interpretation and reporting. Then there's the precip rate underway right there. Okay, switch back to this. And now this is the Esri Alpha display. Basically, they put a risk map down in the lower corner. This would be color coded so that brighter colors would indicate an area under alert, and then you could click on an area and it would show statistics, and they're still working on that part. So that's got a little ways to go. This is the result of a hand calculation where once you've determined the hand elevation raster for an area, it's just a simple raster operation to highlight what would be inundated at a certain height above stream bed. And then, so this, I'm not going to present this as authoritative, but let's say it was about 15 feet above stream bed, and this would be, the red dots were address points found to be in the inundation path. So this is the destination for this process. One caution I will tell you is that there's about 60,000 address points that have a zero elevation above stream depth in the state of Texas, and that can't be right. So please don't take this home and start using it, but I will show you where you can get to it, and we're going to continue doing the quality checks and refining this. Here's a flood inundation map for Brazoria County. Now, Brazoria County is right down on the Gulf Coast, and this is far more flooding than really took place. And the issue is that the height above nearest drainage at 10-meter NED is not an appropriate inundation technique for right along the coast. We're looking at ways, this is current research, for coming up with a better hand result. The height above nearest drainage is a useful flood map, but it's the method for getting to it. First of all, we need LIDAR, and second of all, we need some alternative approaches, because even with LIDAR, you get some strange behavior down when it's too flat. So TENRIS is right now in a process of collecting all these colored areas in LIDAR. We have a real patchwork of varying vintages and resolution that have been collected so far. I have all this, the DEMs from this, and they vary in resolution and quality, and so it's kind of hard putting together a detailed map that's at a consistent sampling. So this is underway. The 4 points per square meter is what they're starting to collect now, and they're trying to map as much as they can. But there's a lot of lower resolution still out there, and a lot of overlaps. Okay, so accomplishments so far: we've collected 9 million address points, the whole state, with varying accuracy. And we've determined the height above nearest drainage for each of those points. There are synthetic rating curves for all the streams in Texas based on an average. And these 100,000 streams they vary in average from, they vary in 2 kilometers to 7, some of them are 10 kilometers, some of them are just on a matter of dozens of meters. And so this kind of throws off the modeling when they're real short, and not just when it's real flat. But we do have work underway to clear that up. So I suspect that by the end of this year, we will start producing some inundation maps that have value. National Water Model launched in August. Kisters has a gauge network, not just for USGS gauges, but also City of Austin gauges and LCRA gauges throughout the state. And so there's a little over 500 about 800 gauges, but we have 100,000 stream forecasts now. So it's supposed to be ESRI statewide impacts map, not ESRO. No new people here. What TxDOT is starting to do is put sensors, flood gauges, inexpensive ones, not like the USGS gauges, on interstate bridges. And there's projects underway to do this and add to the observation network that we can bring to bear on this. We've used quite a lot of supercomputer time, but it turns out that there's some parts of this that you can do for yourself. So this is just a summary, but I want to show you now a little more information about how the hand itself is computed. So here's what hand looks like for Texas. We saw that. You can download Huck 6s of these, and I'm going to show you what those look like. Here's one of the folders of Huck 6 hand for 120902. That's the Huck 6 around Austin. And the process starts with the DEM, and that's this one. This is the 10 meter NID. And and of course these are shape files from the NHD, but it produces intermediate outputs. This is the final output, the one that says hand in it. This one here with SRC is developed by the process, and it's a drain line raster. It's a 1 pixel wide drain line that matches the DEM. So that's the most reliable drain line for the area. And then the hand, of course, is the one I was showing you. Now, you can download those, and you'll notice that they're really quite big. So the hand for that one Huck 6 is 10 gigabytes. The drain line raster is quite a bit smaller. But if you want to get the whole state, it's about 50 gigabytes just for the hand. And you can visualize just the raster with these instructions, which you'll have. This is what that brings up. It's just a tile service. You can't do anything with this except overlay it on Google Map. And but this is what the 120902 Huck 6 hand looks like. And if you're interested in generating hand based on a DEM of your own choice, you can try redoing the ones that they've done up at the supercomputer, but I've actually done this on a desktop. You can download the hand, the TAUDEM process. Now I'm going to switch out of here and go back to the web browser because I've got a, here's the web page. So they just want to know who you are. This doesn't cost anything. There's an open source version, and there's a ArcGIS toolbox version. And so they've got instructions for both, and how you plug it into the toolbox. And then there's a set of instructions which are not there, but I've put together a bit of a tutorial, and this is a workflow that uses only a very small portion of the whole TALDEM library. You can work through this and do the steps that are involved in generating the hand, and this is what close-up looks like of say a basin at a certain elevation. So these are different elevations: 1 meter, 5 meter, 10 meter for one basin. Now this particular basin, I wasn't able to do the entire TALDEM on my desktop. And this is, I'm going to say it's about the size of a Huck 6. So, but I had a 12 gigabyte RAM, and if you have more, it'll probably take care of it. There's only one step that doesn't fit in small memory, and that's this D8 flow generation. As far as this whole workflow goes, I am not a hydrologist, so I cannot answer questions about this, but I do know people who can. So I believe that's the material I've got, and here's the index of Huck 6s. Now they've got the whole country here, so you can you need to have your Texas map if you want to do Texas, but they're all pretty big. Oh, and they do have on this parent directory, they have a zip file of the entire folder. So the 120902, just for grins, was 17 gigabytes. So that's not a pleasant download. Then this is the instructions that was on my slide. They've got that posted. That's this. And then this is the current national water model output. And so I did want to show that. So if we zoom in to an area, the more you zoom in, the more you see all of these streams are mapped. And if I just pick a spot, I'll see what the medium and the short range are. You can turn on long range and rebuild and see, well, they're not projecting very far on that one. We could get this one is got a little more peak going on right now. And this again is cubic feet per second. This is not stream depth, but the Kistler's curve will tell you what that is expecting. So so that's the show, and with that I'll take questions. So I have a question. The slides will be posted on URISA Texas. You'll have to ask Brian. Got a question on the differences are due to how data comes in a data format. Oh, Linda, the differences on what? Just answer in the chat. And then the instruction manual, when you say an instruction manual, are you talking about the this guide right here? Or are you talking about something else? This guide right here is not a big PDF, and it's on my Google Drive, and I can upload it with the PowerPoint.
Nicole, if you're there, this is Brian. I unmuted you. You can see if your telephone works, or you can type it in.
Yeah, no, she did. So now let's see. What is the pixel resolution of the hand raster? That's 10 meters. The hand raster, let me go back to the PowerPoint. This guy right here is at 10 meters per pixel. And there's a question on those. Oh, differences when I was talking about the graphs that showed the forecasts. Oh, okay. There's a data format issue about the different graphs. So I'm not quite sure how much more detail to go in on that. One thing I've noticed is the NetCDF files are really pretty efficient. They're also platform portable, and you couldn't get much more compact. So if there's 33 megabytes for one file, you can expect that to be about 400 megabytes if you blew that up into ASCII text. Question, do we plan to consider geologic and soil data? The geologic and soil data actually goes into the water surface modeling, the land surface modeling that's back in the beginning stages of generating the water model. So this national water model, I've got a whole different presentation on that. I'm not going to try to search for it. But this national water model starts with rainfall. And in fact, I do have something here. Okay, it starts with rainfall, and it converts the rainfall into runoff using a land surface model that is considering soil cover, soil type, ground cover, elevation, and then from the runoff, it computes what the stream flow is in each river reach. So that's in consideration already. And the computation, the rainfall is at a 1 kilometer resolution. So they're doing the land surface modeling at 1 kilometer resolution. It's not bad. One question that wasn't asked yet is, does this take into account reservoir releases through dams? And it can, and in the research community, we have been doing that. The National Weather Service is taking into account reservoirs as passive buffers for the runoff, and they're only doing about 1,600 reservoirs around the country. There's about 130 of those in Texas. But the dam releases are a matter of ongoing discussion. Corps of Engineers owns that. National Weather Service can get that. They're not sure about publishing that. What they're doing right now is they're tweaking their river reach forecasts based on the nearest downstream stream gauge. So they nudge the forecast to the stream gauge and then go from there. And so as river releases affect the stream gauge, then they are reflected in downstream forecasts from that point. But that doesn't address the distance between the dam and the forecast and the stream gauge. But that is something that's possible to work into this whole thing. If we have the data, we can tweak the model so that the river forecast includes the dam releases. And I just not sure why they don't do that. Other questions?
Any more questions? Ollie, I've unmuted you. Okay.
Thanks, Brian.
Well, I guess if there's not any questions, we want to go ahead and thank Dr. Archer for presenting today. And if you do think of any questions, then please you can send them to our email address, and we'll go ahead and try to follow up with Dr. Archer and get an answer to it. So there, I just posted the email. We will go ahead and save this. It's being recorded today, and we will save it on our website. When we send out the PDH, we'll go ahead and send you a link to where it's saved on the website, so you can view the recording. And David, you said you're okay with the PowerPoint presentation being posted, or?
Yeah, it's just a word of warning. It's 100 megabytes, and that's, I was telling Brian earlier, that's mainly because of this one slide right here that's got the animation. It goes down to about 20 megabytes without that.
Okay.
So, but I'll put the whole thing up there, and you're welcome to it.
We'll make it work and get it on a place where everybody can download the full PowerPoint, as well as a secondary one without, in case so you'll have the option. So yeah, we'll take care of that. And all right, well, without anything else, I want to go ahead and thank some of our sponsors, Esri for providing us the Zoom background, and Dunaway for providing continued support. And so, at any rate, David, thank you so much, everybody. I hope you all have a wonderful rest of the day. And is there any other presentations you got coming up, David, that you want to mention, or is this?
I think I'm going to be giving the same one at EWRI, and you probably know about that.
Yeah, I do.
Johnny Sullivan was asking me about that.
Yeah, he's right here. So, and that's on what date? Now you'll be doing that in person.
That's June 22nd, I believe.
Okay, that's on a Thursday, and so yeah, you can check out the EWRI website, and if anybody wants to go see Dr. Archer in person. So
yeah, and if any of you are involved in public safety itself, I can go into more detail about some of what we've done.
Yeah, and you were interested in talking about maybe some of the other stuff you're doing as well. So maybe we'll have you back and do another presentation down the road.
All right, glad to.
And if anyone, we're going to be sending out the certificates within the next week. So if by the end of next week you guys don't receive certificates, please just email us at urisatexas@gmail.com so we can make sure that you guys get your certificates.
Okay. All righty. Well, everybody, you all have a wonderful rest of the day, and we will see you again on June 27th for our next presentation. It's by Nate Harold from NOAA. He is the lead physical scientist for the NOAA Sea Rise Elevation Viewer and the land use viewer. He's going to be talking on GIS data usage calculations to develop the criteria, and this one should be quite good. So again, this is the June 27th, and same time from noon to 1 p.m. Central. So we'll see you all next month.
All right. Thanks, Brian.
Okay, take care.